All right. Hello, I'm Matt Van Vliet, and today we're going to be talking about the technology required in order to build a PSA. And we have a piece we've done previously about the five critical aspects of a PSA. And I have DJ Doherty here with me to talk about the technology required to do some of those things. But before we dig into that, DJ, why don't you introduce yourself and talk about how you got involved in working on this business problem.
Yep. Hi, my name is DJ Doherty. How I got into this is that in many years ago, I started working with a consulting company, and in order to kind of facilitate moving that company forward, we built a product in house that allowed us to do projections and manage employees and manage projects and positions and all of that. And then fast forward to a couple years ago, started my own consulting company and decided that the need was still there. It's still very relevant, and so that's how August or Ogantry came into play. And kind of see a need, fill a need, kind of thing.
Right. So the need for a system was out there, and ultimately some of the more unique things that we've done around projections and around being very forward focused and being able to do a lot of comparisons just weren't in the current products that were out there. So this time we decided to build it as a scalable product instead of an internal tool. Yep. How did you decide in the technology stack that we were using? Is it just, I think there's always a combination of a passion for technologies and learning the new things and right for purpose and right for fit. So maybe talk a little bit about how you decided the technology stack.
Yeah. I think you kind of nailed it. It's what is the tool, the right tool for the right job, and we always think through that. But then there's always the right tool for the right job might not be the newest, most interesting solution. So you got to kind of balance that. And I think in our situation, we obviously, in what 2020 didn't decide to build, a piece of software on COBOL, just not because we couldn't, but just because it wasn't the newest and latest thing that seemed to solve the problem. So when we, kind of started looking at what we had done in the past and the choices that we had made in technology, some of those choices, while at the time I think were the right decisions, those those languages or the language that we were using was kind of sunset and was no longer supported. So it made it really challenging. So looking, at a new version of the application, it was what language do we believe is going to be around for the long haul, and along with that, how do we find a language that is, does it meet all of the criteria of, is it fairly easy to write, write the use to write the software using the language? Does it give us the performance that we need? Are the tool is the tooling in place? Are there libraries that support the things that we need to do so we don't have to invent everything ourselves? So in that case, we looked at being a software consulting company. One of the things that we always look into is, how do we write tests for it? How do we put it into a continuous integration environment? How do we, put ourselves in a situation that we kind of have this saying of, if you come to me and say I need a change in software, how fast can you get that one line of change to production? And the reason we look at it that way is, if we have a defect in production and we have a client that's being affected by it, how fast can we make that change so that they're out of that situation? So given all of those things that I, kind of throw out there as the criteria, we ended up picking Elixir. We're using Elixir Phoenix as the back end. So the back end is written in a way that it is, a REST API. The API is available to any client that we have. they can use it in two ways. They can either use it as a kind of a command line. I want to write my own software so that I can interface with the data that's inside of Ogantry, or they can use the actual Ogantry user interface. And both of those would use the same set of APIs. The advantage there being that all of the business rules that are in place are applied in both cases. But it does allow for situations where maybe on our roadmap, it doesn't call for the feature that they need. It may be very important to a very specific client, but our other clients may not need that. And so we may not put that as high on our priority list. And that gives them the flexibility to, go on their own path and use the data in the way that it is their data. So allowing them to use their data the way they need to. So the other technologies that we're using, because we're using Elixir, we're using Postgres database, and there's some facilities around that specifically Postgres gives us that we'll talk about a little bit later. And then we're also using Gig Elixir, which is a very Elixir specific cloud provider. That the nice part with them is they provide a lot of Elixir niceties that allow us to deploy and do hot deployments and rollbacks and database management and that kind of stuff very easily. But it also allows us to not only be locked into an Amazon or a Google Cloud or an Azure solution. We can actually have varying backends, meaning Amazon or Google Cloud, to provide what we need. That gives us some flexibility, and regionally, where is a client located, we can put servers close to them. Some cloud providers provide things that others don't, so it allows us to pick and choose when it makes the most sense for us.
Yeah, I think you're touching on one of the five attributes of a highly effective PSA around scalability. That ability to scale at the cloud level, the ability to do things both at an API level and at a user experience level. So if you need to add 1,000 projects for some reason, that you can just do that and you don't need to do it through the UI. So I think that scalability comes from that architecture, and it's kind of designed right in.
Yeah, I think scalability was one of the big things that we really thought through when we were building Ogantry. In our past experience, we were, you know, granted, while 10 years ago technology has changed a lot, and the fact that the solution was more of a kind of an in-house, very specific to one company. When you start building software that's runs the risk, but I mean that in a positive way, runs the risk of getting lots and lots of clients. You want to be able to have that ability that you can scale. So Elixir was also chosen for that reason as well. I mean, with Elixir being built on top of Erlang, obviously many years of experience with the phone industry, and the idea that it runs very efficiently, everything's a process. It just makes it very nice that it was almost, and Matt, you can relate to this. I mean, being involved from the very beginning, things that we used to do that took you know an entire evening, we would run them at night because they would not be able to be performed in a way that the front end could handle it. And so when the users came in the morning, they would have their data because of the performance improvements of not only just Elixir and its ability to run quickly, just the change in technology over those number of years. What we used to run overnight, we now run in 15 or 20 seconds. And so it really changed the experience, the scalability of the application, and the idea that one client doesn't affect the other. So if one client's loading thousands of projects into their system, it's not affecting the performance of the other client.
Yeah, so there's scalability. There's scalability for large numbers of users. There's also scalability for large numbers of projects, and then there's scalability for large number of project clients. So one of the things we've had to do is make this to be a multi-tenant application, right? So we can scale to many clients, and there's no chance that one client can see another client's data.
Mhm. Yeah. Yeah, that's what I kind of alluded to that a little bit earlier and said we would talk about it. We're using Postgres, Postgres has obviously come a long way in the last number of years, but one of their I think one of their super features or super killer features is their multi-tenant support. And most databases will do it in some way, but Postgres does a really nice implementation of it, I believe, or I feel like that it allows us to, every client that we have has their own complete database instance, their own schema. There's no crossing of data between client X and client Y. Some database implementations would have one schema with some kind of an indicator to say client X, this is client X data and this is client Y data. Postgres implementation of completely separate schemas I really like because when you get into things of data security and just however far we want to go in this conversation with HIPAA and things like that, it makes it really nice for us to be able to comply with that stuff. It also allows for things like we can do maintenance on one client while we leave all the other clients alone. If there's issue with a specific client, we can deal with that and not affect everybody else. So a lot of advantages in that.
Yeah. Great. So another one of the attributes of a highly effective PSA is being cross-disciplined, and this one may be a little less, kind of impacting the technology choice. When we talk about cross-disciplined, we're talking about having clients and projects and projections based on those projects, and having that projection of where we think we're going financially match the data recruiting is going to see about what positions do we think we need to get staffed or hired, match the sales projection data to say here's the new projects that we think are going to be in the future. So from a staffing perspective, um, from a recruiting perspective, from a sales perspective, having all that data tied together and different disciplines represented, I think has been a key thing to getting that data model correct and understood based on our past lessons. Well, I'm not sure it has any major technology implications. What do you think?
Yeah, I mean, you and I've had this conversation a lot, and obviously, no data model was invented overnight, and they grow kind of organically. I think that's one of the advantages of Ogantry is that we are leveraging all the experience we've had over the last 8 or 10 years. I do think that the data model that we have currently in place has proven to be really solid. We seem to keep throwing situations at it, and we almost always solve it by writing code and not by changing the data model. And so that I think is a really good sign that the data model is solid. um, we talk about it like it's this wildly complicated thing, and it really is not. I mean, I think the beauty of the data model is that it's fairly simple. And I think the reason it's simple and the reason it works is that we really have modeled it in a way that it represents the way the application works, and not trying to force fit that into something that we thought was elegant, or oh, this is the most pure way to implement a database. While I think the database is, it does follow all the the normal forms. There are times where we violate that because it makes more sense from a business standpoint to not have to do all these crazy joins to get the data. Which I think in our case, data is cheap, database storage is cheap, and so we've always kind of looked at the data model as what makes the most sense for the performance and the benefit of the end consumer, and not what makes it pretty and the best solution for us. And it's not always so I think we've done a good job with it. I think it's proven itself. And I think the other thing that's really nice, because we have exposed everything as REST endpoints, it makes it really nice that a you know a fairly well, regardless of how long they've been with us, a client can fairly easily look at the REST calls or all of the services that we expose and say, okay, I have a project. I know that projects can have positions. I want to go grab all the positions from the database, and it just makes sense that they would be linked to projects. There's not all this craziness. So
Yeah, it makes sense. So another, I think, fundamental decision that we made when we started building a gantry was that some of these jobs you talked about running overnight um, were really about being able to see changes over time. So what was my projection today, and then tomorrow I'm going to want to rerun that and understand my projection. And I think we made a fundamental decision that we'd make the database immutable and do effective dating. And um, that's, you know, building on that foundation gives us a huge amount of capability in being traceable. Why don't you talk about that technology and that approach a little bit?
yeah, I think it's interesting when you say that we made the database immutable. I think probably when people hear that, they're going to be like, "Wait a minute, that'll never work." Databases the whole purpose of databases are that we can insert data, we can modify data, we can delete data, and we definitely have those features. And I actually kind of like when you like the way you say it, and when we do say it, people kind of look at us kind of crazy. But the nice part of that is that it gives us a great opportunity to explain what you're calling effective dating, which is what we all call effective dating. So what we have done, so when we were going through this, we have this idea, and I think the industry would call them super killers. I think our super killer that makes us stand out as an application is our implementation of effective dating. And so I think simply put, what effective dating does, just to kind of explain it at a very high level, is it allows us that when we insert data into the database, that record has an effective start date and effective end date. Now, not to confuse that with like an active start date and end date. So, for example, an employee could have a start date and end date. So, the day we hire them, and then the day we would terminate them, or the day they would leave the company, or whatever. The effective dating is what indicates at a given moment in time, what did that employee look like? So when you first create an employee, the effective date, the effective start date, and probably the start date of the employee would be the same. But at some point down the road, you're going to say, okay, that let's just say it was somebody changed their address. They moved from one location to another, and we changed that on the employee record. We don't modify the original record. What we do is we effectively end date that original employee and then create a new employee record with a new effective start date with all of the data copied over to that new record except for the update to the address. Now what that does is a couple things. On the downside, it creates extra records in the database. But like we said earlier, you know, database storage is cheap. Databases are so fast now. I mean, it is not a big deal. But what it allows us to do is that at any record in the system that has been effective dated, it allows us to look and say, okay, what now address might not be a great situation, but it might be for taxes or whatever. It allows us to say today they lived at 123 Main Street and yesterday they lived at 234 South Street. So we can actually see it's almost a built-in audit record. We can see the difference. Now, address doesn't make a lot of sense, but it's I think fairly easy to understand. Where it really comes into play, go ahead, you're going to say something. Yeah, exactly. Salary or costs on employee cost or position cost or durations of positions. You can very easily now say, okay, that position was planned for 6 months, and now somebody changed it to 3 months. In a system that doesn't support effective dating, you have you have to probably go look at an audit log and then you know traverse through that audit log and figure out who changed it, when they changed it, and maybe even go ask them why they changed it. What with effective dating and the way Gantry works, it allows us to be able to do a comparison over time and say, last yesterday that project was 6 months. Today, when I look at my revenue, I'm down X number of dollars. Why? Now I can see very quickly that that position was shortened by 3 months. Obviously, I'm not going to generate as much money, and it's in simple cases like that, they're fairly easy to find. But imagine you have a system that has, you know, 75 projects and 500 positions, and you've got 7 people that are all managing this simultaneously. And when you run the P&L and you see a change, it would be near impossible to find the differences. And so that's why effective dating comes into play. Now, the the beauty. So I'm going to dig in. If I'm going to dig into the technology just a little bit, Matt, just because I'm geeking out at this point. Because we've chosen to use Elixir and because we're building it on top of Phoenix, we have a lot of niceties there. So every entity in the system, think of projects and customers and positions, employees, we've written a macro. So think of, self-defining code. We have written a macro that defines all of that effective dating logic. And then when we define an entity like a customer, we actually just require that to be part of it. And we get that functionality just imported into that entity. So if we find a defect in that logic, we fix it for one and it fixes all. So that makes it really, really fast and nice. But it also allows us to, because of Phoenix, there's this concept of plugs, and so we can inject things in the stream of data coming in that deals with all of that effective dating automatically. So, from a developer standpoint, yes, we did have to write that logic, but anyone new coming onto the project can basically learn how it works and then kind of forget about it. And so that's kind of the beauty of the way we've kind of implemented that. Is the first time we had to do it, it was, yes, complicated, and there was a lot of testing around it. But now that it works, if tomorrow we came along and said, we've got this new thing called a resource location. I'm making that up. But we add this new concept and we want it to be effective dated. All we do is require that macro and it works. And we don't have to go write that again. We know it works exactly like every other piece of, effective dating in the system.
Yeah, and so this ability is really fundamental to some of the things Ogantry can do. Sometimes we talk about it as being like a time machine, right? So you can look at an audit log and go say what happened to this project. But what you can do in Ogantry is you can say, give me the data as of 3 months ago. And you can look at the projects, you can look at the people, you can look at the positions, you can look at the bench report, and you can see all of that data as if you were sitting 3 months ago. And that's incredibly important for traceability. But we also have an attribute of a effective PSA, about being future focused. And I think one of the things about what we are doing is we're predicting the future, right? We're trying to say these are the projects we think we're going to win. These are the people we think we're going to need. This is our best guess today. The challenge with that is there's no way to be correct, right? If you could predict the future, you'd be be a rich person, right? So what you do is you put your best guess in, and then a week from now, you have your new understanding of the current reality, and you want to compare what did it look like, what was reality a week ago, what was reality today, and what changed, right? Because it's going to be highly volatile because you're trying to predict the future. You're going to want to do these variances, and these are things that we used to try to do snapshots and batch jobs to look at, and it wasn't really possible to go back in time and look at. Well, the way we implemented this technology, we can just as quickly look at the data a month ago as we can look at the data today, and then we can very quickly compare it. So I think that future focused thing makes it even more important to have some technology like this. Um, DJ, did you want to dig into any of that comparison or what's necessary in order to do that, or do you think we've covered kind of the underlying technology?
I mean, we can talk about it a little bit. I th- I I think it's a feature that is unique. I mean, I think the idea of taking two completely different snapshots of the database and comparing them, and I think that's an interesting, when you were saying about effective dating there at the end, because effective dating, while it only works on the each row of the database at a time, because of the way it works, what it really is doing is snapshotting the database every time a change is made. And to your point, it allows us to go forward and back. Well, not really forward. Forward is a projection, but backward and compare. So, I mean, I think some of the value or some of the way we've implemented it is we treat everything as a giant map, and so it makes math really easy. We just basically say, this is what it looked like 3 months ago. This is what it looks like today. Do the math. Obviously, you can't subtract things like project name, so we don't do that. But things that are all math related, all number related, it makes it really really easy and really quick. A couple of things that we are doing to make the user experience, I think, more enjoyable, or at least so that they don't know really what's going on. We do implement caching quite a bit, and so if Matt comes in and runs a projection for a given set of criteria, and typically what we find is at certain times during the cycle of whether that's a week or a month or the quarter, people are always doing the same things. You're not, it's not 10,000 different requests for 10,000 different pieces or criteria. It's the whole company's interested in what is the status of this given set of criteria. And so a lot of the things that we do, we're caching so that when Matt runs it, while it takes 15 seconds for Matt to get the entire P&L back, the next time I come in, he's already done the work for me. And so my request comes in, I make the same request. The back end has already done a lot of that work. It's cached it. I will get sub-second response. So I'll generate an entire P&L in sub-second. And so that's really nice because, as the users are using the system, they want to use the system, because that was something we saw in the past was, you know, we kind of joked in the history that we used to do everything on spreadsheets, and the reason we built the system was to get rid of the spreadsheet so we had one place for the data, one source of truth. But because there was one source of truth, and because of the way it calculated and the amount of time to do it, people would still go back to their spreadsheets from time to time. And so the goal of having an application that does all of this crazy calculations and math that give you this, ability to manage your company, but give it to you in an amount of time that you couldn't even like convert over to using a spreadsheet. That's the real power, I think, of Ogantry.
So the fifth attribute of a highly effective PSA is that it's sliceable. And what we mean by that is um, different groups, right? We talked about it being cross-functional. The salespeople want to see the data in it be in sync with the projections that the finance people look at, and in sync with what the recruiters are looking for, and so forth. But that also means that everybody has a different slice of the data that they want to look at. So I may be in charge of the Midwest, so I want to see the Midwest slice, or I might be in charge of the Elixir practice, so I want to see the Elixir slice, or I'm in charge of um, you know you know this type of contractor. So all these different slices. One of the things we've implemented in order to make it easily sliceable is tagging, and and tagging lets you define different ways you want to slice the data, and then very quickly look at those slices. So, do you want to talk about that a little bit? Yeah.
So yes, I agree with tagging. Tagging is I think another one of those super powerful features, because one of the problems that you run into when you build an application, we're sitting here and with all good effort, we're trying to put ourselves in the shoes of our clients, but we never will be able to do that on a very consistent basis. They're always going to want to say, oh, with this employee, because our employees are actually in another system, we'd like to have that system's ID stored into a gantry. And so we have a reference. Well, we'll never be able to predict all of those. Plus, we would never be able to add them one off to account for every possible option out there. So tagging gives us that ability to say, we're not going to define any of that. We're just going to give you the facility to create as many tags as you want, filter them the way you want, use them however you want. Some clients may use them. Think of like Instagram. When I post my Instagram post, I say, hashtag Fort Lauderdale, hashtag sunny weather, whatever. Now I'm able to search and filter on those hashtags, and everybody else in the world is as well. So think of tagging in a gantry as the same facility. The client, the user of the system, can define those however they want. We always talk about regions. Not every client has the concept of regions, or maybe they call them something different. So, I think that's the real power and benefit of tagging. From a technology standpoint, we really struggled with this. This is probably one of the features that you know probably Matt and the business pushed on. Matt probably pushed harder than anybody. I probably pushed in the opposite direction, probably directly toward him, resisting it, thinking, how are we going to implement this in a way that will be performant, flexible, scalable, all the things that we've already mentioned, these 5 things that we've talked about, and then the complexity of allowing them to have infinite flexibility, but also design a user interface around the way to showcase that data and not allow the client to get lost. And so this was another one of those when we kind of had an aha moment. It was one of these late night conversations, and we kind of had been talking about it. I forget the terminology we used, Matt, but it wasn't tagging. But then all of a sudden we were like, well, what about this concept of all these other systems that use tags, these hashtags? And it just kind of clicked. From a technology standpoint, we're using a facility of, in this case, Postgres has it, but obviously other databases support it, but it's JSON B. So what we do is we put all of this data in a JSON B structure and store it in the database along with whatever record we're putting tagging on. And then it gives us the basically the endless flexibility to search and filter on those elements in that JSON B, even though that it's a kind of a structured data. The database gives us the ability to say reach into that payload and kind of tear that JSON B structure apart and say, I'll go use region as my example, but I've said this employee belongs to region West Coast. I can actually filter into that payload and say, give me all the employees in the database that have a region of West Coast. And it's given us this really incredible flexibility to give the end user the ability to create anything they want. I always joke that maybe it's dogs, cats, and donkeys. I don't know if that's a great use case for a business unless maybe you're a zoo, but we're not saying that you have to be specific to these 5 types of tags that we're giving you. You're endless possibility there. And then the other advantage I think is that with tagging, we do have a little kind of a side conversation or a side feature that we call extended fields. They both work exactly the same way, but it gives, and when Matt is selling the product or talking to a potential client and they say, wow, I'd really like to be able to put this in the payload along with that employee or that project. It gives him the ultimate flexibility to say, yep, we can store that. We can do that. We can filter on that. So it's a real powerful thing when you're trying to sell a product and give people the ability to kind of own their data and use it in a way they want to.
So I think the trick there is, like, I want the flexibility where someone says, "Can I put skill set on an employee?" And we say, "Yeah, you can do that," right? And that's something that was even in there before we had tagging. And then they say, "Can I put desired skill set on the employee?" Because I have people who are interested in learning that skill set, and if I can give them the chance, I want them to do that. And then the next conversation you're in, someone's saying, well, can I put willingness to travel on the employee, and then the next person's asking for something else. And it really is what's important to your business. If you're a regional business or a national business or a high tech business, like there's different data you need. So how do we make it so that you can put whatever fields you want in a highly flexible way, but then also make it scalable and sliceable and so forth. So having that technology such that it's essentially in the database index, even though it's not a specific column in the database. Having that power means that we can do a lot with a gantry without polluting it with all types of data that someone needs, but most companies don't.
Right. Right. Yeah. Yeah. And it's very possible that some clients may not even use the feature. Yeah. It just may not be a requirement of what they're trying to do. And that's perfectly fine.
Yeah, so the defined fields are the things that are core and responsible for the calculations and the projections and so forth. And then extended fields and tags are really for all the things that could vary between different businesses. And it's very quick and easy in order to do those things. So that's ultimately the five attributes of a highly effective PSA. And in a second, I'm going to add a sixth one. DJ, hold on. Here it comes. But we talked about it being cross-disciplined and sliceable and scalable and future focused and traceable. And I think all of those are important, and the technology underneath it is critical. I think the other thing that we've done, and I think it's going to become a requirement to really be something that's truly effective, is we've hidden most of this technology to where the user doesn't need to know about it. We talk about effective dating, but really all you need to know is that I want to run a 7-day variance, and then I can get a 7-day variance like that, right? You don't have to know all the underlying technology. So I think that sixth, requirement for a PSA is going to need to be that it's simple, and and that it doesn't, it gives you insights instead of making you wade through mountains of data and reports and options or spreadsheets. That it can tell you, well, yes, you have a 7-day variance. You're projecting to make $50,000 less than you used to, and here's why. These projects were won. This project was lost. These two positions got delayed, and DJ didn't work 2 days last week, right? So sorry to put you in the cause there, DJ. But instead of me having to dig in to all the data and start running reports and trying to figure out what happened, we put that information right in front of you. So insights, providing insights versus mountains of data, I think is going to be an essential quality of something to be an effective PSA. Otherwise, you're spending your time trying to understand what happened in the past instead of working on solving whatever that opportunity is. So that's going to be a continued challenge we have, because we obviously love technology and are building some really cool, slick technology. But to keep it from a user perspective, to be invisible and simple, to say, okay, well, just tell me I need to go look into these 3 projects. Build that insight into the application so that I don't have to worry about effective dating and reports and variances and comparisons and all of these things.